Let's talk about compound interest. Everybody likes to make money. And the question is, how does money actually grow? Well, it grows not by you putting it under your mattress. It grows by putting it somewhere where it can earn some interest. And we're going to talk about compound interest. If I have a sum of money, which I'm going to call my principal, and I'm going to invest it at a certain percentage rate, R, and we're going to express that rate as a decimal and not a percent, and added to the principal at the end of the year, if I'm compounding once a year. And I have so much money, if I have $100 and I'm getting 10%, then at the end of the first year I'd have $110. At the end of the second year I'd have $110 plus 10% of $110. So in other words, your money, you're making interest on your interest when you compound your interest. And A is going to represent what we have after a compounding period, whether it's a year or a month or a day or whatever. So at the beginning, we start off with our principal, and to that we're going to add principal times interest. And when you add the two things together, you have your new amount that is now going to start earning you interest on that interest and principal. So once again, if we have A equals P plus P times R, I can take a P out of here, and I'll have P times 1 plus R. The 1 plus R is how that money grows. Okay? If I start off with $100 and I'm making 10%, then I'd be 100 plus 10%. So if we take a look at time in years and value after compounding, and we're going to start off in year 0. This is when we just slap some money into the bank. And our accumulated amount is the same as our principal amount because we haven't earned any interest yet. At the end of the first year, you're going to have your principal times 1 plus R. And that will be what is left at the end of the year. In the second year, you're going to take what you had here, your principal plus 1 plus R, and you're going to multiply it again times 1 plus R. In other words, we're going to be P times 1 plus R squared. In the third year, you're going to take what you had in the second year, which was your P times 1 plus R squared, and you're going to multiply that times 1 plus R, so you'll have P times 1 plus R cubed. And are you seeing a pattern here? The exponent here on each one of these is the same as the year. So we can come up with a general equation for T years would be A equals the original principal times 1 plus R raised to however many years there are, T. Now, that's in its simplest form, that's how it works. But things get compounded more than just annually. And the more times you compound, the more money you make, because your interest is making money for you as you go through the year. So let's talk about compounding quarterly, which means 4 times per year. So we have our equation, A equals P times 1 plus R raised to the T power. Now we have to take into consideration that we're compounding more than once a year. And if we compound more than once a year, then our annual interest rate is still going to be there, but we're going to have to divide it, because you're not going to get that rate 4 times a year. You're going to get 1/4 of that rate 4 times a year. So rate per compounding period is going to change. If R is 8% annual, then that would be 0.08. And if you're compounding quarterly, that's 4 periods, so it'd be 0.08 divided by 4. Or each compounding period, you're going to make 0.02% interest, or no, 0.02 interest on it, or 2%. All right, per compounding period. Now, your compounding periods are going to be more than just once a year. So you're going to have to take, so if for 3 years, it'd be 4 times 3. For 4 years, it'd be 4 times 4. For 5 years, it'd be 5 times 4. So we have to adjust our formula to account for those 4 pay periods. And we're going to let each period, or we're going to let the number of periods be n. So we finally have A equals P times 1 plus R over n raised to the n times T power. And that is the general formula for compounding, no matter what your compounding is. If your compounding would be monthly, then n would be 12. If it's daily, it would be n would be approximately 365. So let's do an example here. We're going to take $5,000 at 8% compounded quarterly over 5 years. So this is our P, 5,000. This is our interest rate, 0.08 annual. Our compounding periods are going to be 4 per year because it's quarterly. And our T, the number of years, is 5. So we plug this in to our equation. We get A equals 5,000 times 1 plus 0.08 divided by 4 raised to the 4 times 5 power. And that 0.08 divided by 4 is our compounding interest rate. And 4 times 5 is the number of compounding periods, 4 per year times 5 years. So plug that in and you get $7,429.74. And please notice it's 2 decimal places because we're dealing with money. Okay. So continuous compounding uses the value of E. If you take a look at how, if you take one amount of money at one interest rate and figure out how much you would make at the end of so many years after you've compounded it annually, semi-annually, monthly, quarterly, and daily, you'll notice that as the compounding periods get shorter and shorter, the more money you make. Most banks use continuous compounding, and it uses E. It's not much difference between E and daily compounding, but unless you're making a whole bunch of money somewhere, or you have a whole bunch of money to invest. But the equation is A equals the principal times E raised to the RT power, which is PERT. So choose your investment. If I have 2 different investments, I have $8,000 for 6 years, and I have one bank that gives me 7%, which, by the way, in this day and age is, take that because it's too good to be true. 7% paid compounded monthly, and the second bank at 6.85% continuously. And you have to make a decision as to what your best bet's going to be. Now, the 2 interest rates, if the 2 rates were the same, that would be an easy thing. You choose continuous, but the interest rates are a little bit different. The continuous interest rate is just a little bit below what the 7% monthly is, so we have to do our calculations. So, for the monthly, it's 8,000 plus 1, 8,000 times 1 plus 0.07 divided by 12, because there's 12 months in a year, raised to the 12 times 6, which gives us $12,160.84. The 6.85% is going to be $12,066.60. So there's not a whole lot of difference, but the winner is the 7% monthly. So go ahead and do your checkpoint number 7, and I will see y'all in class. Bye.